In this video, we'll talk about the payback period, which, like internal rate of return and NPV, is a capital budgeting technique, but payback period is much different. Rather than being concerned with value creation, payback period is concerned with liquidity and how quickly your investment will be repaid.
The payback period is another capital budgeting technique. It is also very widely used, as is net present value, but it takes a very different approach. It looks at things in a different way, and it ultimately has a different goal in terms of the types of projects it attempts to identify. One reason that we can use this is to supplement work we're doing with other capital budgeting tools. Another thing might be a company may be working toward maximizing shareholder wealth, but the company may fall on very hard times where they're at the risk of bankruptcy. When you get to that point, you have to reevaluate things. And the name of the game then might be staying in business so that you can continue to maximize shareholder wealth. So you have to change your outlook a little bit. I like to think of this more as a supplement, though, to other techniques. So what the payback period represents is the period of time it takes to recover the initial investments made for the project. So if you invested $1,000 in a project, how long does it take you to get that $1,000 back? That's very simply what we're measuring. With NPV, we would say if a project is positive NPV, that's good, we'll accept that. If it's negative NPV, it hurts the value of the company, we'll reject it. With the payback period, the way we decide, we set some threshold. Maybe our threshold is 3 years or 5 years. We want projects that pay us back more quickly than that threshold. To compute the payback period, basically we need the same numbers that we would need to calculate NPV. We need the cost of the project and the future net cash flows. And remember, those net cash flows are a combination of the positive and negative cash flows in future years. And this is the formula. It's the years to recover the cost, so total years, plus what we'll do is calculate a partial year to recover the cost. So we'll go through an example of how this calculation would occur. This is in your book. This is Exhibit 10.5. This sets out the net cash flows each year. Then underneath the net cash flows are the cumulative net cash flows, where we're kind of counting down how far away we are from recovering our money. So I'm going to use this data, but I'm going to go to Excel and we're going to work through this one. Okay, so we have our year, net cash flow, cumulative net cash flow. So we're going to know the year and the cash flow, and we're going to calculate the cumulative net cash flows. Okay, so we have 4 years for this project. The cash outlay to start the project is negative $70,000. The next year, the net cash flow is $30,000. Then $30,000 again. Then $20,000. Then $15,000. So then we're just going to do some addition. Starting off, we need $70,000 to get paid back. Now we're going to take the $70,000 we still need to get paid back, and we're going to add the $30,000. Now we're still $40,000 in the hole. We take our minus 40, add our 30, we're still $10,000 in the hole. But here, if we take our minus 10,000, add 20, we got it. So what that tells us, because between year 2 and 3, that cumulative net cash flow goes from negative to positive, that's the point where we've recovered our money, somewhere between 2 and 3 years. And then what we need to do is figure out what portion of that year. And the way we would figure that out, we would take this amount. We still need to recover 10,000 in year 3. Our cash flow we receive in year 3 is 20,000. So we take 10,000 divided by 20, and that's a half a year. We know it's between 2 and 3 years, so our payback period is 2.5 years. Now this is a little confusing, I think, because 10,000 here represents half of 20,000. So let's just change this slightly. Let's make this 30,000 again. Then we would have 10,000 that needs to be repaid and 30,000 provided in the next year. So then the answer would be 2.33 years. The thing I didn't want to have be confusing there, if we made this 20,000, is whether you're using this 10,000 that's still owed, or the 10,000, which is the difference between the 20,000 and the 10,000. So you always take this number, what you still owe, and this is in the year where you know you get repaid next year. So you take what you still owe, divide by what's provided in that next year. So we know how quickly this project will pay back. Will this project lead to an increase in shareholder wealth or firm value? We don't know. It depends on the discount rate. At the correct discount rate, it would. At a discount rate which exceeds a certain level, it would not. This doesn't get to that question of maximizing shareholder wealth. It just gets to the question of how quick are you paid back. Maybe you find a couple projects, they both have nice positive NPVs, and you prefer to get paid back quicker. Use this as a supplementary tool. So what I said goes to this point. There's no rationale that links the payback method to shareholder wealth maximization. And what I mentioned this also, you may decide to take on the projects that pay you back the fastest. So it's a supplementary tool. You identify some good projects, use this to make decisions between them. A company may be in a spot where they're near bankruptcy because they have a lot of very short-term obligations. And in the short term, they see that they might have trouble paying the bills. If that's the case, you think that might be a problem for your company, then this may be important for you. You may really want to take on the projects that pay you back quickly so you can get those cash flows back into the company and you can pay the bills. Now, of course, you're never going to take on negative NPV projects, but your goals might change slightly. You may give away a little NPV for something that pays you back more quickly because of those liquidity concerns you have. Some other issues with the payback period. It doesn't consider cash flows after the payback period. So in that problem we looked at, after year 3, we stopped looking because we were paid back. Where in reality that project had a life after year 3. So that's a big issue. It doesn't take into account what happens after you're paid back because you ignore that. So we have examples here on this next slide. And also we have NPV listed here. So project A, no problem. It has positive NPV, a payback of 2 years. Nothing really funny happens after the payback period is complete. Project B, it never pays you back. If you never get paid back what you invest, obviously you take a loss. And because you're getting paid back later with dollars that are worth less, that's going to hurt even more. Project C, you get paid back in year 2, but then you have a cash outflow in year 3, so you're in the hole. You get that money back in year 4, so the payback period could be either 2 years or 4 years. So it's not really going to work there. Project D, you have payback the next year, but a few years later, they get you for $5,000. Obviously not a good project to take on, but the payback period is short. And then E, this one I think is put in for a comparison with A. It has a slower payback than A. If you look at it just in that way, Project A looks better, but if you look at the cash flows that occur after repayment, in the case of Project E, there's that big $5,000 cash flow in year 4, which would obviously lead the company to choosing E over A. But if you just looked at it with the payback period, A has a faster payback than E. So you really got to be careful with this. It's not a method you can just apply and say we got it. You have to look at the future cash flows that you might miss and odd situations that would arise. Another big weakness with the payback period is it doesn't take into account time value of money. So you have $500 that you've invested and you get $500 back the next year and you say you're paid back, but you've been paid back with dollars that aren't worth as much. That doesn't make sense. We really need to take into account time value of money when we work with the payback period. And that's what the discounted payback period does. It looks at these cash flows and their values at time zero. It says, when do we get paid back in today's dollars? So we discount all these cash flows at the cost of capital, and that helps us determine at least a more realistic payback period, one where we're taking into account the time value of money. And Exhibit 10.7 gives a nice example of this. We have the net cash flow and the cumulative net cash flow in the top two columns. So for a typical payback period, we would find 2 years. You start at minus 40,000. In year 1, you get 20,000. In year 2, you get another 20,000, and you're paid back. Not realistic though, because the year 1 and year 2, those dollars aren't worth as much. They should be discounted. So that's what we do in row 3. We discount those cash flows at 10%. So now instead of 20,000 in year 1, we have 18,182, and in year 2, we have 16,529. So now if we look at the bottom row, we start with minus 40,000. After a year, we're not down to 20,000 because we're using a discounted cash flow. We're down to 21,818. Adding that next discounted cash flow in year 2 of 16,529, now we're down to 5,289 that we need to recover. So then this is where we do the division I mentioned before. We see that in year 3, the cumulative cash flow is going to go positive. So we know the payback happens between year 2 and year 3. So we take what we still need to recover, that 5,289, and we divide it by that discounted cash flow in year 3, that 15,026. So the 5,000 and change makes up about 35% of that 15,000 and change. Therefore, on a discounted basis, it takes us 2.35 years to recover our money. In practice, I would never use the payback period, but I may use the discounted payback period. I don't think the payback period is great. It's a nice supplement, but if you're going to do that, you have to at least do it correctly and discount your cash flows. So evaluating the payback rule, kind of summarizing this video, it's widely used in business, and it gives a simple measure of an investment's liquidity risk. How quickly are we going to be repaid if we make this investment? How liquid is this investment? And the advantage of it is very, very simple. But please see this as more of a supplement to NPV or internal rate of return, which we'll talk about later, or something that companies have to rely on more when they're in an odd situation and they have extreme liquidity concerns.